All right, so this section, like I said, combines, it goes kind of all the way back from 3.1 to through to the logs. So technically 3.1 itself is not on your test. However, there are things from 3.1 that are in this section, and that's so I put 3.1 to 3.4 on the title because it does go back to 3.1. The only thing from 3.1, two things from 3.1 that are not on your test are the graphs of your exponential functions and the interest problems. So that stuff, okay, not on your test. But you'll see when we get to it, solving exponential functions require the same skills that we did in 3.1, which was where we got the one-to-one property on our exponential functions. So this section is solving exponential and log equations, okay, which means we are now solving. We're saying x equals something. I would say people struggle the most in this section with knowing what to do from the very beginning. Like, how do I start this problem? And there are two main different types of questions. Exponential, in which the word log or ln is literally not there. And then log, which you will see the word log or you will see the word ln. But then within there, there's multiple ways to solve it, okay? So when we're talking about exponential equations, the word log will not be in these equations, in these questions, or ln obviously won't be there, okay? But we can use logs to solve these questions, okay? So the first thing you want to do is, can I change the base to be the same? And that goes back to what we did in 3.1. If I had an equation that said something like 2 to the x equals 16, okay, then I would change both of these so that 2 were the base. 2 to the x would equal 2 to the 4th. And then when the bases are the same, I set the exponents equal to each other and I solve. So that would be an example of what it could look like if they can be changed to the same base. And then we use the one-to-one property to solve them. The second type of example is where you cannot change them to be the same. So these could look like something that says e to the x equals 4. Or it could look like 3 equals 7 to the x. These cannot be rewritten so that they have the same base. And in these cases, the way that we solve them is you can either ln or take any log on both sides of the equation, okay? But you're basically doing the inverse of raising to a power by lnning, we're going to make it a verb, both sides of our equation. So on the left-hand side, we would ln both sides of this equation. What happens to ln of e to the x? Just the exponent, right? So ln of e becomes the exponent, which would be x. And then it would equal ln of 4. If I didn't have a calculator, I would leave it as it is. If I had a calculator, I would physically plug ln of 4 into the calculator. And ln of 4 is 1.386. On the right-hand side, again, there's no way. Okay, so on the right-hand side, we can't change them to be the same base. So we ln both sides of this equation. Now, you could log anything. You could log base 3 both sides of the equation. You could log base 7 both sides of the equation. But in our calculators, the ln is much easier to navigate than a log base 3 or a log base 7, okay? So now if I've got this statement, if it says ln of 3 equals ln of 7 to the x, what happens on that exponent on the right? If I were to expand this, where's the exponent go? To the front. So this becomes ln of 3 equals x times ln of 7. And if I wanted to isolate that x, what would you do? Divide both sides by ln of 7. So x equals, and in the calculator, you're going to make sure to type, so everybody practice it for muscle memory. ln of 3, then close the parentheses, divided by ln of 7, or stack it in a fraction. But when you type it in, you have to close the parentheses after the 3. Otherwise, it will do 3 divided by ln 7 and then ln that, which is wrong. You should get 0.5645, which would be 565. So in general, two different types of exponential equations, where you can change them to be the same or where you can't. We good so far? All right, so here's a bunch of examples. Let's start with A. What can you do with A? Good. I can change these to be the same base, right? What is a power of both a base of both 64 and 32? 2. So I would, if you don't know, because this would be something you wouldn't have a calculator for, I'd take 64 and break it down. 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. And there are 1, 2, 3, 4, 5, 6 2s. So that is 2 to the 6th raised to the 3x. And if 2 to the 6th is 64, that means 2 to the what is 32? Good. 2 to the 5th raised to the 2 plus x. And the one-to-one property says as soon as you get the bases to be the same on either side of the equal sign, we can ignore the bases and stick with our exponents. So I get 6 times 3x equals 5 times 2 plus x. And then solve it like a regular equation. This is 18x equals 10 plus 5x. Subtract the 5x. 13x equals 10. Divide by 13. And x is 10 over 13. Questions on that process? Okay, go to B. Can you do the same here? Can I make this 1-to-1? Yes. 5 to the 2x is obviously going to stay as 5, but 1 over 125 is 5 to what power? Good. 5 to the negative 3. Bases are the same, so we grab the exponents and we solve for x. So we didn't touch the calculator on either of those. These would be on the portion of your test that does not have a calculator. Still with me? Okay, then I get to C. What are you going to do first? Move the 9. So I'm going to add the 9 to the other side, and I get e to the x equals 28. As soon as you see the e, hopefully you're like, there's no way to change 28 to a base of e, so I know I have to ln both sides of this equation. So I'm lnning e to the x, and I'm lnning 28. And what is ln of e to the x? X, and it would equal ln of 28. So up till that part, I didn't need a calculator. I could have this on a non-calculator based question, and I would have to leave it like that. But with a calculator, ln of 28 is 3.332. Still good? Okay. And D, what are you going to do? ln both sides. So ln of e to the x and ln of 4. And x equals ln of 4. 1.386. Now let's say that had said e to the 2x equals 4. Bless you. Still start the same way. I'm still going to ln, right? But what happens this time on the left-hand side? It's 2x equals ln of 4. So after I find ln of 4, I'm going to divide that by 2. So it would be ln of 4 divided by 2, 0.693. Questions on any of those? Still going? You're welcome. All right, so what are you going to do first with A? I'm going to subtract the 7 from both sides. Negative 2 e to the x equals negative 2. Then what? Divide by negative 2. And negative 2 divided by negative 2 is what? 1. Do you need a calculator to solve this? What's x? 1. Close. 0. Yeah. If you ln both sides, so if I ln both sides, I'm going to get ln of e to the x, so x equals ln of 1. And if you type ln 1 in your calculator, it's going to give you 0. But this is another scenario in which you don't need a calculator, because if the result of an exponential function is 1, it means the exponent had to be 0. So a special case in which you wouldn't need a calculator, but you also can't do 1-to-1. All right, so let's look at B. And B is one of those questions that if you know what you're doing, and after you see it this time, hopefully we'll know, it is not hard, and yet people still freak out, okay? This is basically a factoring statement, okay, where I can plug a value in the place of e to the x. So the long way around this is say that a equals e to the x. So I'm literally going to substitute, and in Algebra 2 Honors, you definitely do it. I don't know about regular Algebra 2, but in Algebra 2 Honors, you definitely do this in different times, okay? Maybe not with e, but with other things. And so if I do this, then e to the x, well, e to the 2x would be the same thing as e to the x raised to the second, which means this would be a to the second. And e to the x is my a minus 12. And I'd get a statement like this. Is that factorable? Yes. What are the factors of negative 12 that sum to negative 1? Good. Negative 4, positive 3. And then I can split and solve this. And I could get a equals 4. And I could get a equals negative 3. But are we solving for a? No, right? We made e to the x a, which means I have to bring e to the x back in place of these a's. So e to the x equals 4, and e to the x equals negative 3. So now from there, what are you going to do? ln both sides. So I'm going to ln, I do it 4 times. ln of e to the x cancels, I get x equals ln of 4. ln of e to the x cancels, and I get x equals ln negative 3. With me so far? Okay, so ln 4 is 1.386. What happens when you try to ln a negative number? You get an error because there is no result of an exponential function that's going to give you a negative number. You cannot do this. So we simply throw it out like it's an extraneous root, and I keep just 1.386. The same thing would happen if it was 0. You cannot ln 0. So we can't ln 0 or log 0, and we can't ln a negative number. All right, so if you saw this again, hopefully you'd recognize the type of question it is. And instead of having to plug a in, you can also just factor it as though it's e to the x in the first spot. And then I'm still looking for the factors of negative 12 that sum to negative 1. And then I can split and solve, and I'd get e to the x equals 4, e to the x equals negative 3, ln both sides, and I get x equals ln of 4, and x equals ln negative 3. I'd rule the right side out, and the left side would give me 1.386. So you can substitute the a in if you want. But if you know what you're doing, you also can avoid that step and just make it e to the x in the position that we typically keep x in. All right, we good so far? So those are all exponential equations. They all started in some sort of exponential form. The second part of this section, okay, so what are you going to do? These bases are not the same, yes? Can we change them so they can be the same? No. So what do? ln both sides. So it's ln of 6 to the 3x plus 1 and ln of 11. This time it's not ln of e, right? So this isn't just going to cancel out. But what can I do with the exponent? I can bump it to the front. So this becomes 3x plus 1 times ln of 6 equals ln of 11. Now you've got two options. You could distribute your ln of 6 to both of these and then solve for x, or I could divide both sides by ln of 6. So it's going to cancel here. I get 3x plus 1 equals ln 11 over ln 6. I could do that in the calculator now, but then I got to save it as rounded. So I'm just going to keep going until I'll get all the way to the end where it's just x by itself. So if I want to keep working so that this x is by itself, what are you going to do next? Subtract the 1. So that's gone. And then I get 3x equals ln 11 over ln of 6 minus 1. And the last thing to do to get x by itself would be divide both sides by 3. So that whole thing is going to get divided by 3. So in my calculator, I'm going to do this in multi-steps. I'm going to do ln 11 divided by ln of 6. If I do it as one statement, you got to make sure you close the parentheses after the 11. Then I'm going to subtract 1, and then I'm going to divide by 3. So ln, everybody practice it again, because this is where it gets complicated. ln 11 divided by ln of 6. You should get 1.338, so on. Subtract the 1. Now I've got 0.338. Divide by 3, and I get x is approximately 0.1127, which I'm going to round to 0.113. Questions on that process? So again, I wait till the very end to put in the calculator, but you could do it up here. You can do ln 11 divided by ln 6, hit enter. And then I can subtract the 1. Just make sure you keep using the answer that's stored. Don't round it. Every time you round it, it becomes less accurate. Now, log functions, okay? Or log equations. And obviously, there's more options here, okay? The first one is if there's only one log. So if I had an equation that said log base 3 of x equals 2. Let's keep it simple for now, okay? Yeah.
Did we skip one on that last time?
So if I only have one log, okay, we already had questions like this, right? If I had log base 3 of x equals 2, how would I solve that?
3 of 2 equals x.
Good. I'm going to convert to exponential. So the 3 is going to pick up the 2, drop off, and I get equals x, and so x would equal 9. So 1 log, convert to exponential. Same thing if there's one ln. If it said ln of x equals 2, what is ln? What's the base on it?
10.
Log base what?
10.
That's just log. Log itself is log base 10. What's ln? Log base e. Good. And now I convert that to exponential. I get e to the second equals x. Without a calculator, I'd leave it like that. With a calculator, I do e to the second, and I get x equals 7.389.
Good morning, libraries and teachers.
Okay, next different type of log is that there's one log on either side of the equal sign. So with these, it's just like with your exponential functions. If you had the same base, which means if you have the same log on either side of the equal sign, you can actually ignore the log and you can set what's next to it equal to each other. So if I had log base 7 of x plus 2 equals log base 7 of 10, as long as they are both the same log, so as long as I only have one on either side, and they're both the same log, could be log base 10, which they'll just say log, could be log base a number, it could be ln, right, because that's the same thing. Then I actually ignore the log and I set what's next to it equal to each other, just like I would do with the exponents. So this is also true with an ln, because ln is a log. Okay, and then the last one is if there's multiple logs, which means multiple logs, multiple ln's, because that's a log too, right? On either one side of the equal sign or on both sides of the equal sign. So the first thing you're going to do is condense it down using the rules from 3-3. If it's addition, we're going to turn it to multiplication. If it's subtraction, we're going to turn it to division. And if it has a number on the front, we're going to bump it to the back to be the exponent, okay? And then from there, you'll have two options. Either logs on both sides of the equation, we ignore, we solve, or one log, and you have to convert to exponential. So one example of this is it would say ln of 3x minus ln of 2 equals 4. Actually, let me change this one. Let me do this one. ln 4. So I could technically move this to the other side, then it becomes addition and I multiply these out, or I leave it on the side where it is, okay? And if I want to condense a subtraction statement, what does it become? Division. So this would be rewritten as ln of 3x over 2 equals ln 4. After you condense, then you say to yourself, is this a one-to-one situation where there's a log on either side of the equal sign? Or is this one that I want to convert to exponential because there's only one log? Well, this has a log on both sides of the equal sign. So we're going to ignore the ln. And we're going to say 3x over 2 equals 4. And then how do I solve for x? Multiply by 2 on both sides. I get 3x equals 8. Divide by 3. And I get x equals 8/3. So that involved condensing with the one-to-one. The last option is condensing. So let's say it's log base 2 of 3x plus log base 2 of 4 equals 3. So here's what you cannot do. I cannot move this to the right-hand side and then use the one-to-one property because there's not just a log on either side. If there's a constant mixed in, it messes that up. So I can't say, I'm going to move this to one side, I'm going to ignore the logs, and I'm going to solve for x. You cannot. What I can do is condense that left side. So now it's addition, which becomes what when we condense? Multiplication. So 3x times 4 equals 3. So I'd get log base 2 of 12x equals 3. And now I've got one log on one side of the equal sign. So what are you going to do?
Move it.
Convert to exponential, right? 2's going to come over and pick up the 3. 2 to the third would equal 12x. 8 equals 12x. Divide. And x equals 2/3. With me so far? The hardest part is figuring what to do at the beginning because they're all going to get mixed together. Okay, and then here's the catch with logs, okay? The very bottom bullet says, log expressions are defined only for logs of positive real numbers. So we have to check every solution when the equation starts log. When it starts as log, you're going to take your answers, you're going to plug them back in just at the beginning, and you don't have to plug them all the way in and see it all the way through. You could if you had time just to check your answer. But what you're really checking for is when I plug it back in, am I going to end up trying to find log of 0, because I can, or log of a negative number? So if I just take this, let's go to this one, that I had log base 7 of x plus 2 and log base 7 of 10. And I got an answer of 8. Because there was a log in my original question, there should be like an alarm that goes off in your head that says you have to check these answers. I'm going to take the 8 and I'm going to come up and I'm going to plug it back in anywhere there was an x in the beginning. There's an x here. If I plug that 8 in here, does the thing next to log become greater than 0? Yes, right? If I plug 8 in, this is 10. If it is 0 or it is negative, we take and rule out that answer. We would say no solution here. If there's 2 solutions, one works, one doesn't, we cancel out the one that doesn't work, we keep the one that does, okay? But every log question has to be checked. You get to the end, you go back and you say, can I plug it back in? And if I plug it back in, is what next to my log going to stay positive? As long as it's positive, I can keep that answer. If it's 0 or it's negative, I cannot. All right, let's go to example 3. It says solve the log equation algebraically, approximate your result to 3 decimal places. See if you could do it. All right, so first of all, while you're going through your test on Thursday, my advice is anything that starts with a log equation, put a little star next to remind you I have to check this answer, okay? Maybe don't do it right away. I don't know if it happened last year in Algebra 2 Honors, but this test used to be so long in Algebra 2 Honors that we'd be like, go all the way through, finish, and then go back and check your answers because everybody would be stressed for time. Maybe do that. Go all the way through, but then go back and check everything that has a log answer, okay? Because it's not like a lot of them are going to get ruled out, right? Like maybe you'll get 1 or 2 along the way that become an extraneous root. Odds are it doesn't happen more than it does. So finish your test if you want, but then go back and check everything that has a log equation. So with A, what are you going to do first? What's the base on that log? 10. There's only one log, yes? So I'm going to do what? Convert to exponential. 10 to the second equals 5x. 10 to the second is 100. And then divide both sides by 5, and x is 20. If I plug 20 in here, does that product stay positive? Yes, I get to keep that answer. Go to B. What are you going to do first? Subtract the 5. 2 ln of x equals 9. Then what? Divide by 2. ln of x equals 9 over 2. And then 1 log, yes? What is ln? Log base? E. So the E comes over and picks up the 9 over 2. So E to the 9 halves, 90.017. And then I check. If I come back in and I put that 90.017 where this x is, this stays positive, so I keep it. Still good. Yeah.
So it's only if it stays positive.
Right. If it's 0, you can't keep it. Or if it goes negative, you can't keep it. So like if it's by itself, you're just really saying, is it positive? Keep it. But if there's like a x minus 3 there, now I got to see if my value minus 3 stays positive. All right, example 4. Same sets of instructions. Solve the equation, round to 3 decimal places. What are you going to do with A? Change it to log base E. Log base E of x equals -3. Then? Good. Convert to exponential e to the -3. Don't freak out because the exponent's negative. Can you have negative exponents? Sure. What's it do, typically? It would move it to a fraction, right? That just means it's going to be smaller than e. But e to the -3 becomes 0.0497. So 0.0, well, 9's going to bump the 4. This becomes 5, 0. Check it. If I plug it back in, does it stay positive? Yes. So I'm good. I can keep that answer. Now I go to B, and there's no longer just one log on one side, right? I've got logs on both sides, and I have multiple logs on the left-hand side. So what are you going to do? Condense. This is add, which means it becomes multiplication. Log base 3 of x times x minus 2 equals log base 3 of x plus 4. Now I got log base 3 on either side of the equal sign. So 1 to 1 says ignore log base 3. On the left-hand side, I'm going to distribute. I get x squared minus 2x equals x plus 4. Then what?
Subtract.
Which way you want to go?
Subtract x and 4.
Good. As soon as you see the x squared and the x, hopefully that's like, oh crap, I'm going to have to factor this out. I'm going to get everything to the left side. I want my x squared to stay positive. So I'm going to move this stuff. And I get x squared minus 3x minus 4 equals 0. Are there factors of -4 that sum to -3? Good. -4, +1. Split and solve. And I get x equals 4 and x equals -1. Now I have to check both. So if I go to the top and I check everywhere there's an x, because if it works for one but doesn't work for the other, I can't keep it. It has to work for all 3. So we're gonna test 4 first. If I plug 4 in to the log base 3 of x, it's fine, right? 4 is obviously positive. If I plug 4 into the parentheses of x minus 2 here, I get 4 minus 2. What is that? 2. Is that positive?
Yes.
Yes, good. Go to the last one. I plug 4 in here. I get 4 plus 4, which is? Didn't mean to stump you on that one. 4 plus 4 is? A is 8 positive.
Yeah.
Yes, so I keep 4. That's an answer. Now I'm checking -1. If I plug -1 next to log base 3, can I find it? No. It wouldn't work here. It wouldn't work in the second one. It would work in the third one, right? But if it doesn't work in even just one of them, I cancel it out. And I would only keep the one that works, which means only 4 is an answer. Now let's say this is multiple choice, guaranteed. You get A, x equals 4 and -1, B, x equals 4. And that's why you've got to remember to check these answers. Still good? Okay. Last slide. Solve out equation algebraically, round to 3 decimal places again. This time the log's only on one side, right? So I'm going to condense and then convert to exponential. The minus means what? Division. Now the 3 picks up the 2. So I get x over x plus 2 equals 3 to the second. And be careful there because this is where people, like a silly mistake is multiplying those out. Like people will do 3 times 2. Remember, if you're converting from log to exponential, it's picking it up. So this becomes x over x plus 1 equals, x plus 2, sorry, equals 9. Then what?
Multiply by x plus 2.
Good. Get rid of that denominator. So I'm going to multiply by x plus 2 on both sides. I get x equals, I can distribute 9x plus 18. And then move the 9x on the left with the other x. So -8x equals 18. And divide both sides by -8. X equals -18 over 8, which is -9/4. Bless you. God bless you. And then we go back and check. Can I keep -9/4? No. Okay. It would be like, obviously, if you wanted to keep that as a mixed number, because you'd have to, if it doesn't, let's say it works here, but then it doesn't work there, obviously you got to check both places. I just need to know if it's going to stay positive, and it does not. So I cancel this out, and this would be no solution.